will get 2 MCQ and 1 2-mark question and 1 5-mark question. So total weightage is 9 marks. What is a network? Computer network is nothing but we are connecting different computers together. It forms a computer network. That's the definition of network. 3 types of computer networks. They are LAN, say local area network, WAN, wide area network, and metropolitan area network, that is MAN, that is MAN. Students, welcome to Computer Science Revision Classes. I am Ravi Kumar KR, lecturer in Computer Science, Vidhyaashram PU College, Temple of Excellence, Mysuru. Students, let us start our discussion with networking concept, chapter number 15. The weightage of the chapter is 9 marks. Here, you will get 2 MCQ and 1 2-mark question and 1 5-mark question. So, total weightage is 9 marks. So, in this chapter, we are going to cover the concept like introduction to networking, features of networking, types of networking, network topologies, network devices, and communication medium. Let us start with the definition of what is a computer network. So, computer network is an interconnection of autonomous computer is the definition of network. So, in general, what is a network? Computer network is nothing but we are connecting different computers together. It forms a computer network. That's the definition of network. Now, what are the goals of networking? Let us see the different goals of networking. One is resource sharing. The aim is to make all the programs, data and peripherals available to anyone on the network, irrespective of their physical location of the sources and the user. So this is the goal of networking, resource of sharing. If I say resources, it may be hardware resources, software resources, or computer peripherals. I mean, any devices we are connected to computers are called peripherals. All these are shared in a computer, those who are connected to a network. That is important. So that is one of the goal is resource sharing. Then reliability. So what is the definition of this? A file can have copies on 2 or 3 different machines. So if one of them is unavailable, so other copies could be used. So what is the meaning of this? So here in a networking, different computers are connected to form a networking. So a same data can be copied to another computer. If one data is lost, the same data can be accessed by another computers in networking. That is reliability. Next one is cost factor. So personal computers have better price or performance rather than the microcomputer. So it is better to have PCs on one per user with data stored on one shared file server machine. So the concept here is in a network, it is better to have one system where we can store different software resources or hardware resources, and we have different computers, we can have PCs, so that it is a cost effective factor. I mean, we can use PCs in networking to access the different resources on the computer. So this is a cost factor. Next one is communication medium. So using a network, it is possible for managers working apart, prepare financial reports of the company. So what is the meaning of this? So communication medium. So here, I mean, those who are all connected to a network or in a computer network, they can access or they communicate among themselves or within network irrespective of their physical location. That is the meaning of communication medium. Next, we'll see what are all different types of computer networks. So the networks vary in size, complexity, and geographical spread. So we can have different types of network based on the size, complexity, and geographical spread. See, based on these factors, we have these 3 types of computer networks. They are LAN, say local area network, WAN, wide area network, and metropolitan area network, that is MAN, that is MAN. So these are different types of network based on the geographical location of the computers. Now let us see what is a LAN or local area network. So here it is a small computer networks that are confined to a localized area. For example, in office or a building or a factory are known as local area network. So here local area network is a type of network where the network is restricted to a confined area, local area. Very good example is any small office or a small factory or for example is a computer lab where we can have around 15 to 20 computers in a computer lab, and if you look at the distance between two computers are very minimum. So that is the very good example for local area network. Here the distance between the two computers or two peripherals are minimum. That is the feature of local area network. Now look at the diagram here. If you look at the diagram here, these are all different computers on the network, and here the distance between all the devices or all the peripherals are minimum. That is LAN. So here LAN users can share data, information program, printer, hard disk and modem, etc. Even in the as it is a network, so here different resources can be shared in LAN. And in LAN configuration, one computer is designated as a file server, and it stores all sorts of the software and that controls the network, as well as the software that can be shared by the computers attached to the network. So in LAN concept here, there will be only one computer as a server. If you look into that, this is a server. So here all the software, programs, everything will be loaded here. On all others computers which are connected to the network can access these resources from the server computer. Now computers connect to the file server are called workstation. This is the workstations are nothing but a computer which is on the network. So the workstations may have additional software on their hard drive. So if I talk about LAN, this is I have told you about server, and apart from this we have different computers here. So all these individual computer can have its own hard disk, its own software apart from the network, or the and it can share the resources available in the server computer. So this is local area network. Next we talk about MAN, that is metropolitan area network. So here these networks spread over the city. For example, cable TV network. Here we can talk about a network where you can imagine a cable TV network. Here the cable TV network which are spread over to one location or entire city. Now here you can imagine the distance between two computers, for example, or cable TV connectivity. You can imagine the distance between two TVs or two houses where we are connecting each other. So that is a very good example for MAN or metropolitan area network. Here if you assume that in the LAN the distance is minimum, here in this MAN type of network the distance between two peripherals or computers are more as compared to LAN. Next one is the purpose of MAN is also the sharing of hardware and software resources among its users. So that is the common purpose of networking, sharing of hardware and software resources. Same things applicable even for MAN type of network. This is an example here. Next one is WAN, is wide area network. So next type of network is wide area network. It is spread across the countries are known as WAN. So in the previous, in the LAN, it is restricted only within a small room or to a small offices. But if we talk about MAN, it is spread over the city, and this is WAN, it is spread, the network spread across the countries. That is the difference between this. Now we can imagine the distance between the two computers or two computer peripherals. So all the users can access the same resources, and they can access the hardware and software resources irrespective of the distance between the two computers. That is wide area network. And here it is a group of computers that are separated by large distance and tied together. It can even a group of LAN that are spread across the server locations and connected together to look like a big LAN. So another example of a WAN is, we can also define the WAN is nothing but it is a connection of different local networks. That's also possible. Here one LAN connected to another LAN. It is also an example for wide area network. Now in the next slide, the WANs link computers to facilitate fast and efficient exchange of information at lesser cost and higher speed. This is the advantage of this. Here the speed is increased and it is a cost effective. Next one is, the computers connected to wide area network are often connected through a public network such as telephone system. Here we are connecting two different computers in a WAN through public network, that is a public domain. An example is through a telephone cables or telephone system. And internet is a very good example for WAN type of connectivity. So this is about wide area network. In the next slide, we will see network topologies. What is the meaning of network topologies? The actual appearance or layout of networking. So here the meaning is that, see, even we have computers for networking, so it is not possible for us, or we are not supposed to connect the different computers or peripherals in the network as per our wish. So we have to follow the standard. So here this is the topology is nothing but arrangement of computer or computer peripherals in a network. It is the definition of network topology. Next one is, we have different types of topology. So first one is star topology. Look at the schematic diagram here. This is an example of a star topology. And here this topology consists of a central node to which all other nodes are connected by a single path. Here, this is, look at the example. This is a central node here. And for this, all other computers or peripherals are connected to this through a single path. So this is the connectivity. From here to this is the path one, and this another path, and this. So here all individual computers are called nodes. Here these are called as nodes, are connected individually to the centralized system. So this is star topology. Now what are the advantages of star topology? Ease of service. So here these provide easy access for services, reconfiguration of the network. So here, because the debugging or any problem in the networking, it can be easily recognized and it can be reconfigured and can be solved easily. Next one is, here one device per connection. In the star topology, failure of a single connection typically involves the disconnecting one node from, otherwise it is fully functional network. So here if you look at this diagram here, all these are individual connectors or individual nodes connected to centralized device. So any problem with one of the connectivity or one of the path here, in that case, so only this computer will be out of the network, but otherwise all the systems will work effectively in a complete network. All the network will be on even though there is a problem or the one of the computer is not in the network. That is the meaning of the one device per connection. That is the advantage of star topology. Next we look into another type of topology, that is bus or linear topology. And here, this consists of a single length of transmission medium onto which the various nodes are attached. See here, there is a single length of transmission medium. Look at the example here. So if you look at this diagram here, from here to here, it is a continuous, a single transmission medium. So this is the transmission medium here, and to which all devices are connected independently. So that is the meaning of single length of medium onto which various nodes or computers are connected. The transmission from any station travels length of the bus in both directions and can be received by all other stations. The bus has terminator at either end which absorbs the signal, removing it from the bus. So here any data communication takes place and all the data travels from one end to another end through a single transmission medium, and the data or the messages, whatever it, and it goes to the corresponding machines or the corresponding node which absorbs those data in through this transmission medium. Now the data is transmitted in a small blocks known as packets. In a computer network, whatever the data to be transferred, actually the data will be broken down into a number of packets. It is called a segment, is known as packets. Each packet has some data bits plus header containing the destination address. So the destination device, on identifying the address on the packets, copies the data onto its disk. See, that's what I told you just now. Here, the data is traveled in the form of packets, and each packet has, there are two parts, one part for data and another for destination address, or the address to which the data to be sent. So while the data is, packet is moving, traveling across this medium, the particular computer or a node which accepts it or absorbs the data from the transmission medium to his hard disk, that to his local disk. So this is bus or linear topology. Now what are the advantage of this? This is a short cable length and simple wiring layout. So advantage is that it takes very minimum or a short cable length and minimum configuration. And resilient architecture means there is a single cable through which all the data propagates and to which all the nodes are connected, and easy to extend. Additional nodes can be connected to an existing bus without any point along its length. So here in the bus topology, it is easy for us to add any new computer or any new node to the network. See, these are all advantages of bus topology. Next, see what are all the drawbacks of this. The drawback of this topology is fault diagnosis is difficult, and here that means any fault in the network, it is difficult to identify it. That is, a fault diagnosis is difficult, and fault isolation is also difficult. Suppose if any of the node is not working in a computer network or in a bus topology, isolation of that or removing that node is also difficult. And repeater configuration. So here we are, repeater is a network device. See, we are using this repeater in a network to boost the signal or to strengthen the signal in bus topology. So if we use the repeater in the network, it has to be configured, and node must be intelligent. So what is the meaning of intelligent? In the bus topology, must access the data which are relevant to that particular node. Say, these are the drawbacks of the bus topology. Next topology is the ring topology or circular topology. Now, in this case, each node is connected to two and only two neighboring nodes and is transmitted onwards to another. Now, look at the diagram here. So if you look at this network, this is a ring topology or a network. Here, this one particular node connected to two other nodes. And if you look at this one, this is connected to these two, and this node connected to previous as well as next node. So it forms a circular or a ring topology. Here, the data travels in one direction only from node to node around the ring. So here, the data travel maybe in a clockwise. So from one node to another node. After passing through each node, it returns to the sending node, which removes it. So as the data is passing through the ring network or in the transmission medium, which the particular data goes to respective computer by looking at the address. Otherwise, so again, the same data goes back to the sent computer or the computer or the node which has sent the message. Next, look at the advantages of and disadvantages of ring topology. In advantages, short cable length and no wiring, lower space required, and suitable for optical fibers or OFC. See, these are advantages. And drawback is node failure causes entire network failure. If you look at the diagram here, so in the ring topology, if any one of the problem with any of the node, in this, for this example, in this node, again the whole network goes down, and so network cannot continue or data cannot be transmitted over network. Difficult to diagnose the faults, difficult to identify the mistakes or errors in particular node or in a network, and network reconfiguration is difficult. Any problem with one of the nodes and isolation of the problem is also difficult, and reconfiguring the network or a new node is also difficult. These are all the different disadvantages of ring topology. Next concept is tree topology. So here, look at the tree topology. Here, the shape of the network is that of an inverted tree with the centered root branching and sub-branching to the extremities of the network. So it is just like a tree topology. Here, the network is similar to or looks like inverted tree. So here, if you look into that, see this is the central hub, and to which we have one more hub is connected to this. And here for this particular hub, there are 3 nodes, and for this only 1 node, and for this again there are 3 nodes, and for this it is 3 nodes. All these, it looks like a tree and its branches. So it is called as tree topology. Now here, transmission in this topology takes place in the same way as in the bus topology. In bus topology, how the transmission takes place, that is, all the data, everything transmits from one to another end of a transmission medium. Similarly, it starts from the root. And the tree topology is best suited for applications which have hierarchical flow of data and control. It is best suitable for hierarchical arrangement of network. Since the tree topology is modification of a pure network topology, bus topology, it is called a hybrid topology. So, tree topology, it is a combination of bus topology as well as tree topology. If you look at the diagram here, see if you look at star topology, what is it? Here all the nodes are connected to one central node. So this is example of a star topology. So this is star topology, and only one node connected to this. So all these forms a hybrid network or hybrid topology, or it is a combination of 2 or more topologies. This is tree topology. Next one is graph topology. So what is graph topology? In graph topology, nodes are connected together in an arbitrary fashion. So here, look at the diagram here. You can talk about 1, 2, 3, 4, 5, 6. All are different nodes and how they are connected. Link may or may not connect to 2 or more nodes. And in this example, this is connected to 2 nodes, and here this is connected to these 2 nodes, and so on. But here this is connected to only to this node. There may be a multiple links also, as we have seen here. This is called multiple links. It is not necessary that all the nodes are connected, but if the path can be established in 2 nodes via 1 or more link, it is called connected graph. See, what do you mean connected graph? See, suppose from here, for example, from here to 6 is a data to be transferred, and the data can be transferred from 1 to this, either 2, 0, 1, 6 or 2, 1, 6. See, this is the meaning of, nodes via 1 or more links to reach the destination node. So this is graph topology. Next one is mesh topology. In this, look at the diagram here. In this mesh topology, each node is connected to more than one node to provide an alternative route in the case of the host either down or too busy. So if you look at mesh topology, look at the diagram here. Suppose this is one node. If you look into this is connected to here this node, and to this, and to this, and here, and again. So this particular is connected to all different nodes individually. Similarly, if you consider this node, similarly, almost all the nodes will be having more than 2 to 3 paths to reach the destination or to another nodes. So what is the advantage of this? Here, suppose if a data to be transferred from here to this node, and suppose that this road is busy or this line is a traffic, here next it takes another path to reach the destination. That is the advantage of mesh topology. It is excellent for long distance networking because it provides extensive backup, rerouting and pass-through capabilities. So advantage is that it provides more than one path. Next one is communication is possible between any 2 nodes or in the network either directly or by passing through. When suppose communication between these two, either it can communicate directly from here to this computer, or we can through some other nodes or some other path. See, this is mesh topology. The mesh topology is commonly used in large internetworking environment with stars, rings, and bus attached to each node. And here it is also a combination of different topologies. And this is also ideal for distributed network. And when in a network, each host is connected to other directly, there is a direct link between each host, then the network is said to be fully connected. So if you look into that, if there is all the nodes will be having connected individual to all other nodes, then it is called as fully connected nodes. So students, so far we have discussed about the few concepts of networking, definition of networking, types of networking, and networking topologies. So we will continue our discussion in my next class. Thank you so much.